Bismillahirrahmanirrahim. Hello everyone. I hope you are all fine. My name is Azmat Ali and I welcome you all in class of real analysis. In the last lecture, we have discussed about ordered set and order on a set. In today's lecture, we will discuss two definition 1.7 and 1.8 from the book Principle of Mathematical Analysis written by Walter Rudin. In these two definitions, we will discuss about lower and upper bound of a set, bounded above and bounded below sets, and last one is supremum and infimum of set. So firstly we define what is lower and upper bound of set. Let S be a. Here I will discuss these definitions according to the reference book, that is Principle of Mathematical Analysis here. So according to this book, let S be an ordered set, S be an ordered set. A set is called ordered set if an order can be defined on that set. So let S be an ordered set and E is its subset. And E is subset of S. Then an element beta belong to S is called upper bound of E. Then beta is an element of S and it will call upper bound of E if beta is greater than equal to all elements of E. That is, if beta is greater than equal to X for all X belong to E, then in this case beta is called upper bound of E. On the other hand, if beta is less than equal to X for all X belong to E, then beta is called lower bound of S. Lower bound of E, sorry. So an element is called upper bound of a certain set E if it is greater than equal to all elements of that set E. And if on the other hand element beta is less than equal to all elements of set E, then beta is called lower bound of E. Next, we define what is bounded above and bounded below set. Bounded above and bounded below. If a set E says E, if a set E has an upper bound, then it is called bounded above set. Then it is called bounded above set. And similarly, if a set E has an lower bound, then set E is called bounded below set. Now we discuss these concepts by a simple example. Suppose I have an order set S equal to set of real number R. In the last lecture, I have discussed that R is an ordered set with certain order defined on R. So suppose that our set of real number is equal to S, that is an order set here. And consider E, that is the set of first 20 natural number, that is equal to 1, 2, 3 up to 20. Now, whether E is bounded above, bounded below, and what is its upper bound and lower bound in R. You can see that every number of E is less than equal to less than equal to 20, that is 20 is greater than for all elements of E for all x belong to E. So in this case 20 is here upper bound of E. 20 is here, 20 is an upper bound of E in R. Similarly, you can observe that every element of E is greater than equal to 1. Every element of E is greater than equal to 1. That is 1 less than equal to x for all x belong to E. This shows that 1 is lower bound of E. So in this example, 20 is an upper bound and 1 is a lower bound. Because set E has a upper bound as well as lower bound, so E is called here bounded above as well as bounded below set. Next, we define what is the supremum and infimum of a set. Supremum and infimum of set. Supremum and infimum of a set. In this example, you can see that 20 and every real number that is bigger than 20 is also an upper bound of this set. That is 21 is also upper bound of E. So 21 is also an upper bound. 21 is greater than every element of E. So 21 is upper bound of E. 22 is also upper bound of E. So every real number that is greater than equal to 20 uh, represent upper bound of E. So if a set E has an upper bound, then it is possible that it may have infinite many upper bounds. So the smallest one is called supremum. So we can define supremum and infimum of set as if a set has an upper bound, then it is possible that it is possible that it may has infinite infinitely many upper bounds, many upper bounds. So the smallest, the smallest upper bound, the smallest upper bound among all these, all these upper bounds, all these upper bounds is called least upper bound, least upper bound or supremum of a set, or supremum of set, supremum of set. For example, in this case, in this example, 20 is the 20 is an upper bound of E, and all the real numbers that are bigger than 20 also upper bound of E. But the smallest number, smallest among all these upper bound is 20. So supremum of this set E is 20. That can be written as supremum of E, supremum of E, that is equal to 20. Similarly, we can define infimum of the set. If a set has a lower bound, then it is possible that it may has infinite many lower bounds. So the greatest one among all that lower bounds is called infimum. So the infimum of a set is infimum of set is greatest lower bound. Represent greatest lower bound. In this example, 1 is infimum of set E, and all the real numbers that are smaller than 1 also the lower bound of E. So all the real numbers smaller than 1 are minus infinity to 1. This set shows all the lower bounds of set E. This is the set of R. Lower bounds of E in set of real number R. The greatest one is 1. So 1 is the infimum of set E. 1.5, 0, minus 1.5, minus 100.5, all are the lower bounds of set E. But the greatest lower bound 1. So 1 is the infimum of set E. So the infimum of set E in this case is equal to 1. Next, whether is it necessary that the supremum and the infimum of a set always belong to that set? Like as in this example, you can observe that 20 and 1 both belongs to set E. Both are present in set E. So is it necessary that always supremum and infimum belong to that set? No. This is not necessary that always the supremum and the infimum of a certain set belong to that set. For example, consider an example. Uh, Let us take example is equal to 1, 1 by 2, 1 by 3, 1 by 4, up to so on. Our question is what is supremum of E and what is infimum of E, and also whether these supremum and infimum belong to the given set or not. Supremum of E, and suppose here we want to find the supremum of E in set of real number R, that is our ordered set is here, again set of real number R. Okay, supremum. We know that a real number is called supremum of E if it is greater than equal to every number of E. You can see that the largest number uh, among the element of this set E is 1. So the supremum of this set is 1, and in this case that is supremum of E belong to the set E. But on the other hand, can you find the smallest number of the set E? You can see that these numbers approaches to 0. First number is 1, second is 1 by 2, 1 by 2 mean 0.5, third one is 1 by 3, that is 0.33, 1 by 4 0.25, Next number will be 1 by 5, that is 0.20 up to so on. So we can observe that when we increase denominator, because numerator is 1 fixed here, when we increase denominator, the number will approach to 0. So the smallest number, or in other words, the lower bound of the set E is 0. Infimum of E is 0. Now whether 0 belongs to this set? No. 0 does not belong to the E. So this is not necessary that the supremum and the infimum of the set always belong to the given set. So in today's lecture, we have discussed about lower and upper bound of set, bounded above and bounded below set. Third one is supremum and infimum set. I hope today's lecture was helpful for you. Inshallah, in the next lecture, we will discuss about uh, one of the important example of the book of the chapter, that is related to smallest and the greatest number. Example 1.9. Okay, Allah Hafiz, take care.